Hello everyone! I've already made a couple of videos about trips to the local flea market. It seems like viewers are interested in such videos, so the series will continue. So today I'm going to show you some more cool things that were bought in one trip to the local flea market. And among these items, there are some that will make your mouth water. I don't collect just any junk and try to buy only what I will use sooner or later, in one project or another. Of course, sometimes the collector in me awakens, and I buy some unnecessary things just to have them. But that happens rarely. And I can't resist good things even if they're expensive. So I'll start with a mega awesome item. Sometimes when you see a product, you tell yourself, this is exactly what I need. Here it is, what I've been looking for a long time. A sliding rheostat. I used to come across rheostats quite often. True, they were small educational rheostats, but in recent years even those have disappeared from flea markets. And then I come across this, a real monster, reliable, powerful, and most importantly brand new. Previously, I even considered buying rheostats on AliExpress, albeit in a more convenient form factor, but with less power. However, their price is not small. At a flea market, you can usually buy such things for a more or less reasonable price. I had to shell out $3,000. There was, of course, an attempt to bargain, but the old flea market seller instantly saw the spark in my eyes and realized that I would buy it no matter what. And he didn't budge a penny. I couldn't resist this work of art. So, of course, I bought it. I think everyone knows what a rheostat is for. It's an adjustable resistor that allows you to limit the current in a circuit. In reality, such a monster solves a ton of problems. I have all sorts of electronic loads and even a rheostat of quite high power, but it has stepped current adjustment. And electronic loads are undoubtedly good, but they are designed for use in direct current circuits. But this beast doesn't care whether the current is alternating or direct. It doesn't care about the frequency or the shape of the pulses. Additionally, rheostats are extremely reliable due to the absence of semiconductors in their design. In general, you'd have to try really hard to burn it out. There are a lot of limitations, though. For example, the small range of resistance adjustment, which sharply limits the applications of rheostats. You can only fully load it at certain current and voltage values. In electronic loads, there are no such limitations. In the case of this particular rheostat, there's another drawback. You can't quickly set the required resistance. Full adjustment takes 90 turns. It's long and tedious. Maybe in the future, I'll automate this process by installing a slow-speed motor with a gearbox. But for now it'll do. The rheostat's design is simple. There's a winding on a pair of ceramic sleeves. Possibly, not chrome. A slider and terminals. Each winding has a resistance of 25 ohms. Wire with a diameter in mm. The rheostat is made very solidly. There are ceramic insulators. No expense was spared on materials. The slider contacts have copper inserts. There are no identifying marks, so I can't say what it's from. Similar ones I found online, but not exactly like this one. If you have any information on this, please leave a comment. The next purchase is an educational microscope Uman. It's not fully equipped, bought for just 300 rubles. I got it purely to turn it into a drilling machine for printed circuit boards. It can be modified without any issues. Overall, it's the perfect option for a mini drill. The microscope is in decent condition. Only the mirror is missing. For this project, a motor like this was purchased. DPM30N1-02. A Soviet engine of a special class. Such engines were often used in military applications. It has enhanced dust and moisture protection. This is a DC commutator motor with excitation from a permanent magnet. Supply voltage, 27 volts at 3,600 revolutions per minute. The power is just over a watt. But this motor is perfect for drilling boards. What makes this engine special is that it is practically silent, extremely reliable, and durable. It uses ball bearings. The engine has no holes or slots, so nothing can get inside. Dust, that will be generated during board drilling. Overall, it's the perfect option for these purposes. Previously, I came across similar motors, but unfortunately, they were not in working condition. This particular sample works perfectly. Another motor was purchased from the same person. This is also a DC commutator motor, but this time with electromagnetic excitation. These motors have several advantages. Firstly, the magnets won't weaken over time because there simply aren't any. Also, metal shavings won't stick to the motors. Our motor is quite powerful, up to 40 watts. Power supply is 27 volts. The shaft runs from up to thousands of revolutions per minute. It is assembled very well. Again, it has ball bearings, a quality brush assembly with replaceable brushes, and a securely sealed armature. I haven't found a use for it yet. Maybe I'll install it in a mini drilling machine. Or perhaps I'll make some kind of portable drill. Both motors cost me 500 rubles. Electrolytic capacitor, made in France. Previously, I bought good but low voltage capacitors from the company Sprague. This is a high voltage capacitor, rated at 450 volts, and with a capacity of 4,700 microfarads. I don't really need this capacitor, but why let a good thing go to waste? It only costs 200 rubles, and it would be a shame not to buy it. Electrolytic capacitor rated for 85 degrees, designed for use in direct and pulsating current circuits. And most importantly, it has very low internal resistance, only about 20 milliohms, and features a screw-type mounting. It can operate in very high current circuits. I can already imagine the power supply that will house such a capacitor. It will come in handy for me when I decide to build, well, for example, a thermonuclear reactor. For those who are into railguns, such a capacitor is a real find. The capacitor is preserved in excellent condition. The capacitance is slightly less than it should be, but that's within the margin of error. The energy that such a capacitor can store could move mountains. That's of course a joke, but with a grain of truth. I'm itching to charge it and then fire it once, but I think I'll refrain. The next purchase is a popular Soviet mechanical micrometer negative 2,550 Malawian kwachas. In its original box, the micrometer is used and it has served faithfully for more than one owner. Most likely it worked in some kind of production. The original certificate is even preserved. I probably won't be using this micrometer, because for my needs a regular, more versatile caliper is sufficient. I bought it solely because it was a working tool and served the country, passing from hand to hand. It has its own history, and the wear and tear only emphasize its noble past and make you treat it carefully and with respect. The micrometer was disassembled, adjusted, and now it works as it should. There was also a length measure or a 25mm standard in the box. Along with the micrometer, I bought a couple of calipers of Soviet production. When I got home, I partially cleaned them. I have a modern digital caliper, but after using the mechanical ones, to be honest, I really like them a lot. You don't have to worry about replacing the battery or resetting to zero. And the accuracy is quite sufficient for my tasks. The micrometer and the large caliper cost 200 rubles each. The small one was 120 rubles. And I bought this trinket just because it's hard to find a practical use for it right now. It's a load fork, intended for testing batteries. The contacts are connected to the battery, a certain current flows through the load, and the voltmeter shows the voltage drop on the battery. This way, you can understand how dead the battery is. The design is simple. A needle-type bidirectional voltmeter, and a load in the form of two parallel connected coils. Judging by the fact that the voltmeter is only 3 volts and the distance between the contacts is small, it can be said that this device is intended for use with alkaline batteries. Perhaps at one time, such a fork was a mandatory attribute in depots. A rather interesting curiosity. Well, and then there's the small stuff. In this bag, there are about 700 grams of pure pine rosin made in the Resistor. I use rosin as the main flux, and therefore the consumption is high. Of course, you can buy rosin in stores, but in this quantity, it would clearly cost much more than 150 rubles. That's exactly how much this cost me. For someone, this might be a lifetime supply, but I will use up this much rosin in 6 months, maybe a year. An 800-watt network heating element. Soviet, from the year 1980, most likely from some kind of stove. It's working, and I bought it for just 50 rubles. I intend to someday make an automatic press installation for transferring the printed circuit board design from thermal transfer paper to copper-clad fiberglass. And for these purposes, I need a heating element. I think this one will be just right for these purposes. The heated surface in the installation should be perfectly smooth, but nothing prevents it from being on top of this thing. To install, for example, a polished aluminum sheet. And at the end, I'll show valuable acquisitions, at least for me. So I'm walking around the flea market and I come across a piece of fiberglass. I assemble prototype power boards for debugging on similar sheets. These can be used to create, for example, enclosures or bases for some circuits. I ask the seller for the price. The person says, just take it. I felt a bit awkward, and I wanted to buy a few trinkets to at least thank the seller somehow. And then he tells me, I have large pieces in my booth. A fiberglass, if you're interested, you can take a look. In the end, I stumbled upon a real find. Here's that large piece of fiberglass. Its dimensions are 115 by 85, with a thickness of 5 millimeters. It's the perfect solution for making all sorts of enclosures, handles in general. In my opinion, one of the most versatile materials. I took this piece and was about to leave, and then the seller says to me, "Don't you need a second one?" By the second one, he meant this. A huge piece of double-sided copper-clad fiberglass with a thickness of 1.5 millimeters. Taking it out, I saw that its condition was perfect. I'll say more, it's practically new. The dimensions are 95 by 95, not counting the unevenly cut part. I think it is worth explaining why a radio amateur needs foil-clad fiberglass. There's no necessity. Let me emphasize again that the sheet is made of fiberglass, not phenolic paper, which I really dislike. Regarding the cost, all of this cost me 1,200 rubles, and that's very cheap. A small piece of copper-clad fiberglass with dimensions, say 20 by 20, would cost 200 to 250 rubles. From China, it might be even more expensive, although it all depends on the region and where you buy it. And on that note, our video for today comes to an end. Don't forget to leave your feedback on videos of this nature. If you're interested, such videos will be released more often. Well, with that, I can only say goodbye. As always, it was Kasianake, and until next time, bye.